Okay, LT2 and 3, we are going to estimate the value of square roots of whole numbers and solve equations using square roots and something called cube roots. So let's go ahead and get some definitions down first, and then we will put this to practice. So the square of a number just means that it's the product of a number and itself, or a number to the second power, and we've seen these before. So if we have 4 squared, that means that we are taking 4 times 4, and that answer would be 16. Go ahead and write that down. It's just a good reminder that it does not mean 4 times 2, but sometimes it's easy to make that mistake. All right, now the other thing we want to write down is that negative 4 squared is equal to negative 4 times negative 4, and a negative times a negative is a positive, so it turns out that if you square negative 4, you also get 16. Now here's something that sometimes you come across that you need to be aware of. These parentheses are actually important. It tells us that we want to square this whole number, the whole number negative 4. What happens sometimes, especially on calculators, is people write it like this. They write negative 4 squared without any parentheses. But your calculator is so smart that it does order of operations, so it squares this number first and gets 16, and then it says, oh, plus you want it to be negative, so it's negative 16. That's not the case. So when we write it, we want to write it in parentheses to avoid that mistake. All right? Now the square root is just the opposite of a square. So that just means, like if we take the square root of 16, it's saying what number do you square to get 16? Well, we know that that would be 4 and negative 4, because 4 times 4 is 16, negative 4 times negative 4 is 16. The square root of 25, another common one, would be 5 and negative 5. So it's just the opposite. It's the numbers that you would square to get this number. All right, something you might not be familiar with would be the cube of a number and the cube root. So the cube of a number is the product of a number multiplied by itself 3 times, or a number to the third power. So if we have 4 to the third, that is 4 times 4 times 4, which is equal to 64. All right, so that's not so bad. Then the opposite of a cube is called a cube root, and the way that we write this is we write the square root symbol. So I'm going to write the square root of 64, but we want the cube root. So the way that we denote that is we just put a little 3 there. And that says, what number do you multiply 3 times to get 64? Okay, so again, what number do you multiply 3 times to get 64? All right, now we know from what we just did that you multiply 4 3 times by itself to get 64. So the cube root of 64 is 4. Now the negative trick doesn't work over here, because if we took negative 4 times negative 4 times negative 4, we'd get a positive 16, but then we'd end up with a negative, because you'd have negative times a negative is a positive, times another negative is a negative. So with cube roots, you don't have to worry about the negative. All right? We're going to go ahead and write down some common squares, square roots, cubes, and cube roots. Now, the more of these that you have memorized, the easier it becomes to work with these numbers. So I would say for squares, you definitely want to know 1 through 10 squared. 1 squared is 1, 1 times 1 is 1, 2 squared, 2 times 2, 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5, 25, 6 squared is 36, 4 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared would be 100. Again, we could keep going. 11 squared is 121. These are never going to stop, because you can always have a number and square it. Now in the last video I talked about this pattern that's kind of nice. Sometimes when you want to list them out real fast. This increases by 3, then it increases by 5, then it goes up by 7, then it goes up by 9, then it goes up by 11. And that pattern keeps happening where you keep increasing it by 1 more. So it goes up by 13, then 15, and so on. Okay, so that's just a pattern that happens with these perfect squares. All right, now let's look at the opposite, the square root. So the square root of 1. What times itself will give you 1? Well, here's where we're going to get 2 answers. Okay, 1 works because 1 squared is 1. But negative 1 also works. I'm going to put that in parentheses. Okay. Oftentimes we're going to just look for the positive square root. The reason is we're looking at like lengths of something, or things that have to be positive, like the length of a box or something like that. But it's true that the square root is also the negative number. So the square root of 4 is 2. Well, it is also negative 2, because 2 times 2 is 4, negative 2 times negative 2 is also 4. The square root of 9, well, that would be 3. Okay, 3 times 3 is 9. One way in math that we write that it can be the positive and negative is we write plus and minus in front of it. That tells us that the square root of 9 is positive 3 and negative 3. So let's just go ahead and write it that way. The square root of 16, positive and negative 4. Square root of 25, positive and negative 5. Positive and negative 6 for 36. Positive and negative 7 for 49. Positive and negative 8. Positive and negative 9 for 81. Positive and negative 10 for 100. Okay, these are called the perfect squares. Might want to jot that down. We talked about it a little bit in the last video. All right, so then we have cubes when we take a number multiplied by itself one time, or 3 times. So 1 cubed is 1 times 1 times 1, which is equal to 1. 2 to the third, or 2 cubed. 2 times 2 times 2 is equal to 8. 3 to the third. 3 times 3 is 9, times another 3 is 27. 4 to the third. 4 times 4 is 16, and 16 times 4 is 64. 5 to the third. 5 times 5 times 5, or 5 times 5 is 25, times another 5 is 125. These start growing pretty quickly when you're cubing numbers. We're just going to stop there. You could keep going, obviously. And then the cube root of 1. So we're saying, what number do you multiply 3 times to get an answer of 1? Well, that's 1. What number do you multiply 3 times by itself to get 8? That number is 2. We know that from this table over here. Now, like I said, the negative doesn't work over here, because you'll end up with a negative times a negative times a negative. These two will make a positive. Positive times a negative equals a negative, but these are positive numbers. So we only have to have one answer here. What number do we multiply by itself 3 times to get 27? We know that that is 3. What number do we multiply by 3 times to get 64? That's 4. And what number do we multiply 3 times by itself to get 125? That's 5. And those are the only ones we're going to worry about for now. If you could have these 5 memorized, that would make your life easier in this unit. Okay, so let's put this to work. If you flip to the next page, one thing that we're going to do is we're going to estimate the value of these different numbers of square roots and cube roots. So this says to place each number on the number line, and we want to be as exact as possible. So our number line just has whole numbers, and then these are obviously square roots in this case. So I'm going to evaluate these. We know that the square root of 9 is 3. And if it doesn't have a negative out in front, we're just going to assume that it wants the positive answer. So the square root of 9 is 3. Okay, B, this it says is equal to negative, or the opposite of the square root of 25. So the square root of 25 is 5, and now we know it's looking for the negative one. So negative 5. All right, so let's go ahead before we do any more and label those on the number line. So A is at 3. I'm going to draw an A there. And B is at negative 5. That wasn't bad. Now C. Okay, so C is the square root of 18. Square root of 18 is not a perfect square. It was not in this table of perfect squares. 18 would fall between, we can see right here, it'd fall between 16 and 25. So that's how I'm going to estimate it. Okay, the square root of 16 comes before it, and we know that that is 4. The square root of 25 comes after it, and we know that that is exactly 5. So I know that the square root of 18 is between 4 and 5. And the other thing I'm noticing is that 18 is closer to 16 than it is to 25. So it's going to be closer to 4 than it is to 5. So it's going to be like 4.1 or 4.2 or 4.3, something like that. I'm just going to go ahead and say that it's about 4.2. I'm going to use a squiggly equal sign to show that it's approximately equal to 4.2. Not exactly, okay? It keeps going. So that means for C, I'm going to go ahead then, and that's at about 4.2. So So 4.5 would be here, right in the middle. So I'm going to say that C is about here. Okay, D, negative the square root of 3. Well, I'm going to use the same logic. Square root of 3 isn't on this table, but I know that it's going to come between square root of 1 and square root of 4. So let's go ahead and write that. I know that the square root of 1 is 1, and the square root of 4 is equal to 2, so it's going to be between 1 and 2. Okay, but this time it's closer to the 4. It's closer to this one. So I know that it's going to be like 3.5 or 3.6 or 3.7, 3.8, something like that. I'm going to go ahead and say 1.7. I think I was saying 3, but we know it's between 1 and 2. So it's going to be like 1.5 or 1.6 or 1.7 or 1.8 or 1.9. So I'm going to say 1.7, okay? Because again, it's between 1 and 2, and I know it's closer to 2 because 3 is closer to 4 than it is to 1. Okay, but now I'm noticing that we have this negative, so this is actually negative 1.7, about. It's an approximation, right? So D is going to go negative 1.5 would be here, so negative 1.7 is close to negative 2, so I'm going to say that D goes about here. And then lastly, E, square root of 6 is not a perfect square, okay? But I know that 6, where's it going to go? It's going to go between 4 and 9. So that's what I'm going to do. The square root of 4 is equal to 2. The square root of 9 is equal to 3. So it's between 2 and 3, 2 point something. But now I'm seeing that 6, well, 6 is closer to 4. They're only 2 away. 6 and 9 are 3 away. So I'm going to say that it's about 2.4, okay? Because it's, we're going to round down on that one because it's closer to 4. So 2.4, 2.5 would be right in the middle, so it's a little bit closer to 2. And E is going to go right there. All right, so when you're placing these numbers, sometimes you know exactly what they are, like A and B, but oftentimes we have to do some estimation like we did on C, D, and E. So let's look at that in a little bit more detail. Which two numbers is the square root of 62 between? Okay, so we're trying to think of perfect squares. So let's go ahead and put square root of 62 in the middle. Now what's the one that would come right before it? Well, it's 49. What's the one that would come right after it? It's 64. Here's how I know that. I go back to my chart and I'm looking at the square root of 62. So it has to go between these two numbers. 49, 64, 62 fits between those. So I know it's between those. Now I know the square root of 49 is 7. I know the square root of 64 is 8. So that means that the square root of 62 is going to have to be 7 point something. Now you decide, is it closer to 64 or is it closer to 49? Well, it's obviously closer to 64. They're only 2 away. Okay, so it's going to be like 7.5 or 7.6 or 7.7. It's probably going to be 7 point, pretty high up there because 62 and 64 are really close together. Okay, so I'm going to say that it is about 7.9. Okay, so which two whole numbers is 62 between? If we're going to answer that, we're going to say that it is between 7 and 8. Okay, between 7 and 8. And then it's closer to 8 because 62 is closer to 64 than 49. So 62 is closer to 64 than it is to 49. So in this case, this is what we had to answer. Okay, it's between 7 and 8, and it's closer to 8 because 62 is closer to 64. All right, let's look at the next one, the square root of 40. Okay, same kind of thing. Let's put the square root of 40 down. Okay, then the ones that come on either side of it would be the square root of 36 and the square root of 49. I know that the square root of 49 is 7. I know that the square root of 36 is 6, so that means the square root of 40 is going to be 6 point something. So let's go ahead and just write our explanation right now. It's going to be between 6 and 7. Okay, remember it's going to be 6 point something. And then it's going to be closer. Well, let's figure out which one it's closer to. Okay, the difference between 36 and 40 is 4. The difference between 40 and 49 is 9, so it's closer to 36. So that means it's going to be closer to this number. So it's going to be closer to 6 because 40 is closer to 36 than it is to 49. Okay, so it's between 6 and 7, and it's closer to 6 because 40 is closer to 36. All right, so that's how we can estimate what a square root is going to be, even if it's not a perfect square. We can get a pretty good idea of what it should be. All right, let's go ahead now. The other LT is solving equations using square roots. All right, so when we solve equations, a couple of things we have to remember. Whatever you do to one side, you do to the other. And then remember, we often think in terms of opposites to undo these operations. So if we know that this b squared is equal to 100, to get rid of a square, you do the opposite, you take the square root. So go ahead and show that. And then the square root and the square cancel out, so we just get b is equal to, and then the square root of 100 is 10, and actually it is also negative 10. Remember we talked about that? So our answer would be, like one way to write it would be that b is equal to positive and negative 10. Okay, here's how you can check that. It says square b, and you should get 100. So if b is 10, 10 times 10 is 100. And then negative 10 times negative 10 is also 100. So either one of these works out. All right, on to the next. X squared is equal to 23. The square root it, those cancel out. So we get x is equal to, now here's the deal, the square root of 23 is not a perfect square. If we did an estimation, it's between 4 and 5. Okay, it'd be between the square root of 16 and the square root of 25. So it's going to be 4 point something. Just like FYI, it's approximately 4.8. However, the best answer we can give mathematically is to say that x is equal to, this is actually kind of easy, we just write the square root of 23. And then to be like super complete, we write positive and negative. So this is just saying whatever the square root of 23 is, that's what you should square to get 23. Kind of seems like you're cheating, but it's the best answer because otherwise you have to round it. And sometimes rounding isn't great. All right, number 3. X cubed is equal to 8. Well, the opposite of cubing is the cube root. So we take the cube root. Remember, it's a square root sign with the little 3. We have to, whatever we do to one side, we do to the other. This cancels out the cube. So we have x is equal to, then the cube root of 8 is 2. Remember, 2 times 2 times 2 is equal to 8. So that's our answer. X is equal to 2. I like to write it kind of over here because with my line it sort of looks like a 12. And then I can check it. 2 times 2 times 2 is equal to 8. All right, this one, the square root of x is equal to positive and negative 5. Well, let's just think about what this means. It means what number would you take the square root of to get 5? What number would you take the square root of to get 5? So think about that. All right, so you probably have that in your head. To show the work, we say, okay, the opposite of square rooting is squaring, so we square both sides. 5 squared is 25, and negative 5 squared is also 25. So that's the answer. Well, think about it. If we plug in 25 here, the square root of 25 is 5. It's also negative 5. So that one's kind of working backwards a little bit. All right, the next one, the cube root of 51. Okay, cube root symbol. To get rid of that, well, this is one of those, the 51 is not a perfect, it doesn't come out to be a whole number, the cube root of 51. Okay, so the best way to write this, since it doesn't come out evenly, is just to say it's the cube root of 51. Now, if you had a calculator that did cube roots, which some of them do, that's going to be equal to approximately 3.71. And then it actually just keeps going. You could also estimate that because 3 cubed, we know, is, if we go back to our chart, 3 cubed is 27, 4 cubed is 64, okay? So if 3 cubed is 27, 4 cubed is 64, and we want an answer of 51, it's going to be between 3 and 4. But again, the best way to write it is the cube root of 51. And then the last one here, b squared is equal to 81, square root it, and when you do that, these cancel out and you get b is equal to, well, the square root of 81, that is a perfect square, it's 9, it's also negative 9, so you could write it like that, or kind of the fancier way is to say b is equal to positive and negative 9. 9 times 9 is 81, negative 9 times negative 9 is also 81.